Hi, good morning, everyone, or afternoon, depending on where you are logging in from around the world. We have a good audience today. A lot of folks signed up for this. Really excited. Thank you for joining us. As we're getting started, a couple of things. I'm your host, Michael Ortega. I lead marketing at Predabase. I'm going to walk you through some logistics. I also put into chat real quick, if you are interested in following along during the live demo portion, the second half of the webinar that Deb will be doing, we put a link there. You can sign up for Predabase, the platform, for free. Get started and instant access to the platform. So if you want to follow along, I recommend filling out that form because it has to go through a slight sort of approval process, and then you'll be able to start using it and follow the use case that Deb is walking through. Super excited to have everyone here. Today we're going to talk about how to go from engineer to machine learning engineer with the power of low-code declarative machine learning using tools like Predabase and open source Ludwig. I'm going to talk briefly about our webinar logistics. Just to remind everybody, the lines are muted except for the speakers, myself and Deb here. But we do encourage questions, so please put your questions into the chat. We'll do a live Q&A at the end, so we'll try to get to every question, but I encourage you as you're sort of listening along and have questions about the things that we're presenting, please put in the chat. We'll get to as many of those as possible. Reminder as well, as I said earlier, if you're interested in trying the platform or following along in the demo, you can go to that link right there, pbase.ai/get started, request free access to the platform and get started instantly. And that's about it for logistics. Brief intro here. Michael Ortega, Head of Marketing at Predabase. I'm joined by Dev Rishi, co-founder and Chief Product Officer at Predabase as well. And before I pass over for Dev to do a little more intro and go into the content, I want to let folks know that we also have some polling questions as folks are logging in. If you want to sort of answer those, we're just curious to see where folks are in their sort of machine learning journey or journey with large language models, how they're approaching them. And if you want to see sort of how others are thinking about it too, the results will be shared. So you can take a moment to answer those responses. All right, with that, I'm going to hand it over to our speaker today, Dev Rishi. Take it away.
Hello, everyone. Like Michael said, I wanted to double down and say thank you so much for joining this morning, afternoon, evening, or wherever it is that you're joining from. I'm extremely excited to be hosting this topic today around how we think about going from engineering to machine learning engineering. As a brief background on myself, my name is Dev. I'm one of the co-founders for Predabase, a low-code AI platform that's really built on top of open source foundations. And prior to this, I spent kind of a long career in machine learning across a number of different teams, everything from Google Research on productionizing ML to being the first PM on Kaggle, a data science and machine learning community that really saw a large proliferation in terms of users using AI applications. And I've really gotten passionate about how to increase the access for ML. And so I think it's going to be a very topical conversation for us today. I want to start off by acknowledging that the breadth of AI projects that folks have tackled in the industry is enormous. It's everything from the fraud detection notification that you might get on your application that's preventing you from using your credit card in a new country, to the really scary videos that we've seen about deepfakes, are powered by various AI models. And one thing I want to acknowledge is that the diversity of techniques that essentially allow a user to be able to build these AI models is as diverse as the use cases themselves. My goal in the next hour is to give you the toolbox that would allow you to be able to accomplish any of these use cases. Anything from a standard structured tabular prediction task all the way to more cutting edge generative tasks and everything in the middle. And so over the course of this webinar, I hope you walk away feeling like you have the tools and frameworks to be able to do any of the types of machine learning tasks that you've seen overall in industry. Now, I want to start by acknowledging that, as an ecosystem, we've been discussing democratizing machine learning for quite a while. I think it really started in 2011, 2012, when folks first started to get excited about this idea of ML and what deep learning in particular might be able to do. And every year since, it's felt like we are really kind of on the cusp of being able to actually increase access by an order of magnitude the number of folks that are able to execute machine learning. But I think if a lot of the folks are on this call wondering how to go from engineering to machine learning, part of the reason is some of this hype has been disappointing. I think in a large way that's been true until perhaps earlier this year, when many of us have had a chance to use large language models. Now, you've probably in this audience used an LLM yourself before. Perhaps you've used something like ChatGPT or one of the OpenAI APIs. And what's really great about them is that they're extremely easy to be able to use to get started. You can write a single query and get a series of answers. You can ask it to do anything from writing you a knock-knock joke to writing you code that you might be interested in doing for your particular task. But when we work with our customers and organizations that are using Predabase on the low-code ML side, what we realize is that especially when a user starts to see the value with something like ChatGPT, the next question becomes, how do I really use now AI in a real production application system? ChatGPT was great, but I don't need my point of sale system to be able to recite French poetry. I need to be able to solve a specific business problem. And our view at Predabase is that increasingly, engineering is going to be the ones that are leading the charge for machine learning. Every company that we work with is looking to become an AI company or one in which it embeds AI as a deep or differentiated part of its services. And typically, product and engineering teams tend to be the one that face the dilemma of how to be able to actually integrate this into the offering. Every product and engineering team that I've worked with has had an item on their roadmap to use machine learning to do XYZ: personalization, recommender systems, fraud detection, content moderation, building a chatbot. There's so many different use cases that I think people have been looking to be able to build, but it tends to be something that gets pushed out quarter over quarter because it's something that actually can be quite complex for an organization to figure out how they actually want to operationalize. As an engineer looking to do a machine learning project inside of an organization, the first thing you need to, new thing that I think has really been unlocked is that you really have two paths towards how you might think about solving your ML problem. On one hand, you have large language models, which can be really effective and powerful, but perhaps limiting. And on the other hand, you have supervised machine learning, how machine learning has been done over the past several decades. And these types of approaches are in some ways complementary, but also can be used for different types of tasks. The benefits of large language models is you can get started very easily. There's no label data required. You can start to query it without having to actually train the model. And for a lot of NLP and natural language generation tasks, it can be very effective as a method. But we see a lot of drawbacks towards large language models as well when they're not applied in the right circumstances. They can be quite slow, and so latency is a concern because they're very large and also expensive to run, usually on several GPU clusters. Typically, the vast majority of organizations today rent their large language model. They don't own them. They use an API at something like OpenAI or one of the other large language model providers and necessarily have to send their data over the public internet to be able to use those. And these large language models can be really difficult to customize when you want it to actually change the types of outputs that that's generating to be something different than what it was trained on. On the other side of the house, we have traditional supervised machine learning. This would be all the types of machine learning applications you might imagine, let's say pre-2022. The benefit of supervised machine learning is you can tackle many different types of tasks. Anything from fraud detection to being able to do personalization, recommender systems. You can do many of these things that have been developed over the past few decades, and it's quite efficient as well. The size of the model that you might need could be an order or 2 orders of magnitude lower than what you would be doing with a large language model. But your challenges here are going to be that they require ML expertise, require model training, and requires labeled data as well. So as an engineer, one of the things I want you to be able to think about is that oftentimes when you're looking at an AI application, the first thing you might want to decide is, can I solve this using an LLM, or do I want to use supervised ML? And I want to provide like a simple framework as well for how you might choose between these and when you might choose between these as well. Generally speaking, we suggest that if you have a generative use case, for example, I want to write product descriptions, or you don't have a lot of labeled data, it's really useful to be able to start with a large language model. However, if your use case is predictive and you do have labeled data and real-time inference, so really low latency is critical, that's where we can start to do supervised machine learning. And the really great thing I hope about today's presentation is I'm going to show you examples of how easy it can be to actually do both inside of one integrated framework that's really backed by open source foundations. Now, knowing which is half the battle, but there is a second half, which is actually being able to operationalize your chosen method of doing AI in production. And here we see that many organizations hit the AI iceberg, which is that I've determined how I want to solve my ML problem. Now I actually want to get into being able to operationalize it. And what we realize is that there are many layers in the stack in terms of where this complexity starts to come in. The first might be just starting off with model ownership. So how do you actually decide if you want to, let's say, build or buy the model? The second will be model fine-tuning or customizing your model. This is something that oftentimes requires some amount of machine learning expertise, some amount of the bespoke code to be able to be rewritten in lower level frameworks, and quite a bit of iteration on the behalf of the user. Everything from your plots to your .py files are going to be essentially proliferating on your laptop locally as you start to go ahead and iterate on these. And then finally, you actually have deployment. Here, I think one of the main issues that a lot of our users see is just the infrastructure headaches it requires to be able to get a model efficiently trained, distributed, and deployed in production. And so in summary, I think what happens is, even though we've made a lot of progress in terms of where machine learning is, engineers tend to be roadblocked still by a build versus buy decision where neither option is attractive. You can either rent a model or you can decide to go into one of these lower level frameworks and customize your own. Limited ML expertise. I like to say no one wants to get a PhD just in order to be able to solve this quarter's task. And so how do I get to learn just enough so I can solve my problem without having to get the entire depth of background? And then, of course, the infrastructure headaches. How do I make it so I can solve all the challenges from distributed training through model serving and deployment? Now, one of the reasons that I think we feel very passionate about the solution here is that we've seen it firsthand. My co-founder, Piero, was developing machine learning applications at Uber, and he worked on a number of different applications. He first started working on intent classification. So there was text coming in from riders on Uber, and he needed to classify what they were looking for. Now, he was using what in 2018 might have been considered a large language model, something like a BERT, to be able to solve this. But it still took him several months to be able to develop this model and several more months to be able to build and operationalize. His reward for being able to solve this first problem was to then be able to work on the next one, which was working on a fraud prediction problem. It looked a little bit different, so it also took several more months to be able to develop and several months to productionize. And this case kept going on and on with each marginal use case that Piero would build at Uber. And Piero likes to say that he's a lazy data scientist. So he doesn't want to keep reinventing the wheel. And he feels like he can't actually keep writing the same bespoke low-level code every quarter after every quarter with the request of each new product and engineering team. And so he thought a little bit about how he wanted to simplify this process. And we drew inspiration from declarative approaches that have simplified many complex tasks. The key idea behind a declarative approach is that we're going to have a system that allows the user to specify what they want accomplished, and the system will figure out how. A few examples of really useful declarative technologies are, for example, how dbt has made data engineering really easy for data analysts, or how Terraform has made setting up cloud infrastructure very easy for DevOps teams. And now it's really machine learning's turn. How do we make machine learning as easy to be able to go ahead and set up for engineers as some of the other frameworks in the declarative world? And so what Piero arrived at was being able to do declarative machine learning in a configuration-driven way. And this underlying configuration is open source and available through a framework called Ludwig, which we'll share more about in the chat. Ludwig essentially allows you to do your entire machine learning journey, all the way from setting up your data pre-processing pipelines to doing post-processing, directly through a really simple configuration. One of the really nice things is that you can actually essentially set up your very first model inside of Ludwig, usually just in a handful of lines of configuration, defining what you want to take in as input and what you want to predict as an output. And this can support every task from an LLM to more structured tabular tasks like fraud prediction or regression. Every customization you want to make in Ludwig is just a single line. So you never have to implement the code to be able to use a new cutting edge model or to use a new training loop or write hyperparameter optimization. Instead, you can just specify and expand the configuration in one line to be able to change or tweak any part of your pipelines. And what that means is that Ludwig is able to provide you a single interface that can solve many different types of use cases. And what you can see on the left is the different configurations that you can use to be able to use, for example, a transformer model to do translation, text generation using other items, image captioning with ResNet using pre-trained image transformers. All of these are essentially architectures and machine learning pipelines that are possible for you to be able to use in just a series of small configuration files. And as a non-ML expert, you can get started just by writing a configuration that says data in and data out. And as you get more advanced in your journey, or you want to add additional complexity, you can make those changes or additions in just a single tweak of a line of configuration. Ludwig supports an entire spectrum of the modeling interface today. We like to say that it's one configuration that can rule them all and allow you to do everything from linear regression to OpenLlama, one of the 65 billion parameter large language models. And this kind of model flexibility really also extends to task flexibility. So you can do everything from image captioning to structured tabular regression and output. And so what we think the implication is that Ludwig in a declarative programming framework can make machine learning really easy for engineers, because instead of a build or buy decision, what you really have is a way that you don't have to reinvent the wheel. You can get the best of both worlds, an easy build that looks like a buy, building state-of-the-art machine learning pipelines in just a few lines of YAML. Instead of having really limited ML expertise, you can just pick the parts of the model that you want to control and allow the system to be able to automate the rest. You don't need to understand all the depth of it. You can just choose the individual parameters that you care about. And with Predabase, instead of infrastructure headaches, you can reduce the infrastructure friction. Support for things like distributed training and many other optimizations come out of the box. And that's how you can know that you're using the best practices without having to implement them directly yourself. And so with this type of declarative system, what we've seen and what we saw firsthand at Uber was, instead of taking several months for each of these projects to be deployed, instead an engineer would come to Piero, for example, and ask him, I want to work on a use case for website personalization. And one of my favorite narratives is Piero took the meeting and in 30 minutes wrote a configuration file in an email, sent it over to the engineer in one day, and they were able to productionize that model at the end of the week. So instead of having to go through this long, arduous, bespoke custom code cycle, instead it was as easy as copying and pasting a configuration inside of an email. Now, the truth is, while this, I think, is really groundbreaking for a lot of the folks that haven't had an opportunity to see declarative machine learning in practice, the large tech companies really kind of know that this works. The large tech companies like Uber, Apple, and Meta all have their own internal declarative machine learning systems. Ludwig was Uber's declarative machine learning system and has the benefit of being open source. So anyone can go ahead and try it. You can get started with it at ludwig.ai right now. Overton was Apple's internal declarative machine learning framework that feeds a lot of the traffic on systems like Siri and fed billions of queries to date, and has Apple's posted blogs and papers about that. And then Looper was Facebook's internal machine learning platform that also took a declarative approach. It feeds millions of predictions a second as of just last year. However, it's only available internally. When we spoke to an engineer at Meta earlier this year, they mentioned that it was one of the fastest growing frameworks, because for engineers, it sort of provided training wheels for being able to do ML. A very easy way to get started, but still get you to the destination that you needed to. With Predabase, our company, built on top of Ludwig as an open source framework, our goal is to bring declarative machine learning to the enterprise. So how do we make this a tool that every organization can start to access, not just Uber, Apple, and Meta? The key idea behind Predabase is we're going to take this core idea around declarative model training, which was built around Ludwig, and we're going to build an end-to-end platform around it that allows you to build, iterate, and deploy your models. It'll start, as all good ML platforms do, with connecting your data. And from there, you can build your models, and we've built interfaces to be able to track, compare, and refine these over time, as well as deploy them for real-time inference or batch prediction using a new novel language we call PQL, predictive query language. And we'll get to during the demo just into what that actually looks like. The best part is that all of this is really built on top of fully managed and scalable machine learning infrastructure. So you know you're getting all of the best practices right out of the box. And declarative ML has not only been helpful for us and in terms of the organizations that we've worked at, but also some of the organizations we've worked with. And so we've seen a number of different engineers across a number of different types of organizations be able to build use cases very quickly, especially those that deal with unstructured data using this framework. One of my favorite quotes is from Harsh, who heads machine learning and AI at Ku, a large social networking company in India, who mentioned that declarative ML makes it easy for their team of data scientists and engineers to train state-of-the-art models on top of large volumes of unstructured data, so that they can personalize their user experiences. This group is building state-of-the-art, cutting-edge models that help them get much better performance inside their application, and doing so in weeks instead of months that it normally takes a lot of bespoke model training and building. So we're really passionate about being able to empower engineering teams with declarative machine learning. And what I want to be able to show you is that there's really two options for how you might want to get started. If you're interested in just the open source, you can get started with Ludwig.ai. You'll get access to this declarative configuration system that can do everything from allow you to query a large language model to be able to train a more bespoke and custom model. And what I'm going to show you next is Predabase, the low-code declarative ML platform that's a managed version that allows you to build privately hosted custom AI models and large language models in just a few lines of code. And I'm going to, in just a second, hop over to a demo where I'll show you a little bit of what it could look like in practice to be able to work in our system. And you can request a demo or a free trial just at the URL that's provided there. So with that, let me go ahead and switch over to a live demo for you all. Cool. So this is the Predabase platform. Essentially, there are three key things that you can do in the Predabase platform. You can connect data sets, train and build models, and you can query those models as well. Now, when you first land inside the Predabase platform, you can actually go ahead and start to use any of the number of open source models that we have available immediately. So this is our query editor. What you can see is there's a text box where I can ask any question and a number of different open source models, as well as some controls that I have around those open source models that are available directly through this dropdown. For this demo, I've deployed 3 different open source models like Vicuna, Flanty5, and Red Pajama 7 billion. These are 3 different models that have done pretty well on the Hugging Face leaderboard, but you can actually access and deploy any open source model that you've seen on Hugging Face, for example, including some of the latest ones. And what I think is really cool is you can get started just in a simple query. So I could say, what is the capital of Italy? And get started in order to be able to run predictions against this model. And you'll see it's quite fast. The capital of Italy here is Rome from Vicuna 13 billion. So I got that right. Now we might want to switch over to slightly more interesting styles of queries. And maybe, I'm actually in Napa Valley today for a company offsite. So maybe I'll ask it, can you recommend me a nice dry wine? And here, well, I think what you'll see is that this will run. And it'll say that there's many different types of options that are there. So dry wines can be characterized by a lack of sweetness. There's a few options that you might want to try. A Pinot, a Sauvignon Blanc, and then it looks like it was about to say Chardonnay. And if I wanted to go ahead and increase the number of new tokens, perhaps I'd be able to complete that response as well. So this is great. It's been able to give me a recommendation for a nice dry wine. But the truth is, I don't want a recommendation for any wine that exists on the planet. I have a very select series of wines. Perhaps they're the wines that exist on the menu at my vineyard here, or they're wines that exist in a wine cellar, or that I've just seen from like a particular retailer that I like. The key idea is that I don't want to go for open-ended any wine on the internet. I want now to be able to use my particular data that I have on wines and give me a recommendation inside of my data set only. So inside of Predabase, what this will look like is first connecting data and then being able to query the model directly. Now, here's the part where I want to mention that everything that I'm going through in this part of the demo, you can actually try alongside of me for free now. You can go to predabase.com request a free trial, and in a few minutes, you'll be able to log into this environment and do any part of these flows. So if you're interested, please go ahead and get started on the platform for free directly on our website, and you can actually replicate everything what we're doing. And I'll make it really easy to replicate what we're doing because I'm actually going to connect a public data set that we have offered out of the box. So if you go into Predabase right now, you can click Connect Data, Public Data Sets. So these are a series of data sets that we offer right out of the box. And you can scroll down all the way to the bottom to this wine reviews data set. You can choose to import it. And when you import it, you'll be able to take a look at what this data set looks like. Predabase provides you an out-of-the-box data viewer. And so you can see many different things like what are the types of countries that were represented in the wines and what else existed in this wine reviews data set. Here you'll see that each row in the wine reviews data set is about a specific bottle. And so it includes both the text of the reviews, when you might want to drink it, for example, in this case with raw oysters or ceviche, as well as what the score was and the variety of the wine. So what the kind of wine was and the region. So this is the wine reviews data set. It's a collection of, in this case, about 100,000 different reviews of wine. And now what I want is I want my large language model to not make me an open-ended recommendation on a nice dry wine, but I actually only want it to be able to recommend wines that are inside this reviews data set that I have. All I'll do is I'll go to this data set to index dropdown, select wine reviews from there, and I'll execute this query. And what this is going to do now is it's going to allow my large language model to read all the data that's relevant in the wine reviews data set and come up with an answer. And if I click into the answer here, what you'll see is based on the provided context, so the data set that I pass in, a dry wine with high points and a reasonable price would be the Pinot with 89 points and a price of $22. So this has gone from a very open-ended, general, there's 3 different wines that exist, to a very specific wine that exists inside of my data set. And the really fascinating thing is all it took for me to be able to do that inside of my data set here was to be able to actually just select it from a drop-down menu and go from there. What I want to be able to show next is that, because all of this data or I have 100,000 rows of data, I might also want to run a prediction over each row. And so here, I'm going to not index the data, but I'm actually going to run batch inference. What batch inference will mean is that I want to run a prediction per row of the data set. And so what I'm going to ask my large language model is take in all of this data, each review of the wine, and classify the variety of each wine. So you'll notice that actually ran pretty quickly. So, and we spent a lot of time essentially optimizing batch prediction so you can do high throughput with large language models. So here's a little bit of what just happened. Essentially, each row in this particular data set is going to be the description of the wine, the provenance. And then here you'll see that based on the description, the large language model is coming up with what the variety of the wine is. And it's getting it quite right the vast majority of the time. And so this large language model is able to do classification tasks right out of the box. Now with wine, this is pretty cool. I can go ahead and predict the variety essentially just based on the description very, very quickly. But you can imagine many other classification tasks that you're trying to do where you don't have a lot of labeled data and you want to be able to use your large language model in order to be able to generate batch predictions very quickly and efficiently. Now, the last kind of cool example I want to show you of something you can do with batch prediction as well is be able to run a more classically generative task. So I'm going to go ahead and copy and paste this. But essentially what I'm going to say is here, go into each row of my data again. And here's a description of the insert variety wine. And here's the description. Can you name a good occasion for it? Be concise. Let's see how it does on this particular task. So what's going to happen when I execute this is the large language model prompt is going to run against every single row in my data set and ask it to be able to write what a good occasion for this wine could be. And so as I go through it, here's where you can see the responses are. So for this Cabernet, a hearty meal with bold flavors such as lamb or beef might be a really good set. For this Pinot, a casual dinner with friends or wine and cheese party. And so this is actually, I think, really fascinating. Essentially, what I've been able to do is take an entire data set, allow the LLM to just get the parts of the data set that I think are relevant. So I didn't tell it to make a description based on the price, although I could have. I said, just based on the variety and what the wine review description was, can you name a good occasion? And the model was actually able to do a really good job of it. And I think this is a really powerful thing that LLMs are able to do. But the truth is, LLMs are amazing for some sets of circumstances. And if your use case matches any of the ones that I just showed you, it's a great place to get started. But they might not be the perfect fit for all of my data sets. So what I'm going to do now is load a different data set. It's a data set of Twitter users. So instead of each row being a wine description, each row here is going to be a Twitter user profile. Essentially, it's going to be some information about the Twitter user, like how many favorite followers, friends they have, an image for that Twitter user, which is really their profile picture. And what I want to do is ask my model to classify each user as a bot or a human. Now I'm going to run this. So now I'm running this particular LLM query over my Twitter bots data set. And so when this kind of executes, we'll be able to see what the data set looks like, as well as what my LLM was able to generate for a prompt. And this task is quite a bit trickier than the one that I threw at the LLM previously. And you'll be able to see why. For each Twitter user profile, what I have is some text, which really talks about the description that the user wrote for their bio, but a lot of other metadata. For example, what their profile picture image was, how many favorite followers, friends there were, some really unstructured information like the profile picture image. And finally, I'm trying to predict this final column, whether or not the user is a human or a bot. So this is the Twitter bots data set. It's available as well inside of the to be able to connect inside of the Predabase platform. And I think it's a really interesting one of multimodal machine learning. So here I have both structured data like favorite followers, friends, unstructured data like the text that a user may have written for themselves in their bio, and really unstructured data like the profile picture image. And we'll see that the LLM can sometimes predict which user is a human or a bot, but the vast majority of the time, what the LLM will actually say is that it's not possible to classify the user as a bot or a human. And it'll actually tell you, the input is a dictionary containing information about a Twitter user, but it doesn't have enough information to help me indicate whether that user is a human or a bot. And that's because it's harder for the LLM to take into account a lot of the non-text data, like the tabular numbers and images. And so if that's really the case, then I think, it becomes a lot trickier for us to be able to think about how I could actually use machine learning to be able to solve this very real bot detection problem. But the nice thing is, at the beginning of the presentation, I told you that at the end of this session, I wanted to make sure you felt like you had the tools to be able to solve many different types of machine learning tasks. And that includes this bot detection one. So what I'm going to show you is how Predabase can actually make it really easy to go ahead and start to be able to run predictions with an LLM. And in the cases where you decide you want to actually build a smaller, more custom model that might work better for the modalities of data that you have inside your data set, how you can build, operationalize, and serve that model as well. So let's get started. This is my Twitter bots data set. I can actually go in again into my Predabase data viewer and take a look at all the information that might be relevant for the Twitter bots data set. So I have my favorite followers, friends, profile picture, images, and I'm trying to predict this final column of whether or not this user is a human or a bot. My LLM did not perform that well on this particular task out of the box. And so what I want to do is train a smaller custom model on it. Predabase makes that really easy. Inside of Predabase, we have this concept called model repositories. And a model repository is essentially a collection of different models. Each of one is just a configuration file that has been trained to be able to solve a particular task. And building your first model in Predabase is really easy. Now, the key idea behind a model repository is to borrow some of the best practices from GitHub and engineering and bring them to the ML development lifecycle. So I can create a new model version just by clicking this button, and you'll see what the steps are in order to be able to train a new model. So here I've decided I want to build a custom model. Now, building a custom model has many benefits. It takes a few more steps, like you need to train your model, but it's a lot faster and more efficient. And it also can be a lot smaller, so cheaper to serve. Once I've decided I want to build my custom model, all I do is I point it at the data set that I want to be able to train on. So in this case, I want to train on the Twitter bots data set. And you'll see I can train many different types of models, from neural network models all the way to fine-tuning a large language model itself on this particular task. Now, the first thing you'll notice is I extract out a number of features from the data set. Predabase extracts out a number of features from the data set that might be relevant for the task that you're trying to do. For example, you can see the text description, how many favorite followers, friends the user has, the profile picture image, the account type are all extracted out. And in order to train my first model, all I do is specify the column that I want to predict. So in this case, I want to predict the account type. I can click next, and you can actually see that state-of-the-art machine learning pipeline is already generated for me. Everything from data pre-processing through modeling coding and predictions on the other end are generated for me, and I can actually click train immediately. Now, one of the great things is we've already given you what we think are the right recommended starting settings for every part of the model journey process, just by you telling us the data set that you want to do and the column you want to predict. However, machine learning tends to be a very iterative journey. So while all of our users start by taking our recommended default settings and training their first model, after they've trained their first model, they like the ability to be able to customize any part of this pipeline. And you can actually go in and click in to train and customize any part of this pipeline. For example, I can change how my text is pre-processed. I can use a different tokenizer. I can handle missing values a different way, decide if I want to lowercase strings, and so forth. I can also choose from any number of cutting-edge state-of-the-art text models that I can use out of the box. So I can use a large language model like GPT, or I can even use a good trade-off between performance and accuracy, like something like a BERT model, which I can use pre-trained and then easily fine-tune on my data set in just one click. And so what this is going to do is take a pre-trained model with all of kind of the prior information it has from its original data set, and then fine-tune it so that it works very efficiently and effectively on top of my data set. And if anyone's familiar with more parameter efficient techniques of how to be able to fine-tune models, like being able to use LoRa, you can also do and select any of those in just one click from a dropdown. What all this kind of like machine learning pipeline customization is really doing behind the scenes is just tweaking the open source configuration. And so if you wanted to do this programmatically or through a config, you certainly can do so. And so what you're able to get started with essentially is a model that is pre-configured for you, but one that you can customize down to the level of code that you're interested in, and make sure that you have a pipeline that satisfies the journey end to end for what you might be, what might be the most useful in your task. The other kind of like hidden hero, I would say, or unsung hero for Predabase is that we also not only handle the complexity of modeling, but also the complexity of the infrastructure required to train these models. So because we know both the model architecture that you want to choose, which is just this configuration, as well as the data set that you're looking to run on, we can right size the compute that makes the most sense for your task. This means choosing the number of CPUs, GPUs, memory, all of it just gets recommended for you out of the box inside of Predabase and can run in a serverless way on this concept called engines. Engines are essentially a serverless abstraction on top of compute that will turn up when you want to go ahead and start to use your training process and then automatically spin down once your training is done. So you can really efficiently just use the amount of compute that's needed for your particular task. And so when I click train, all the infrastructure, all the complexity of modeling, and everything else is handled for me. And instead, I get to just sit back and watch my model train. And I can show you what a little bit of this actually looks like. You can see that in this particular model repository, we've made a number of different tweaks. Many users have actually gotten in and collaborated. So my colleague Abe actually started the first model repository, and then I took it from there and trained a few others. Justin got involved, and you can see the entire lineage of models directly from this view. So from where we started all the way to the end. And because these models are just configurations, it actually becomes very easy to diff two model versions to get a sense of what were the changes that we made. So if I diff model version 2 and model version 8, I can see that the only real difference was that I decided to use a BERT text encoder for model version 8. And so that becomes a very easy way for me to be able to make side-by-side comparisons without actually having to compare thousands of lines of code. If I look at all of my model versions, and perhaps I have a model version that I want to dig a lot deeper into, I can click into it and actually get a sense of all of its different metrics. I can get a sense of what its accuracy was across training, test, and validation sets, AUC, loss, all the different metrics that I might be interested in are all here, including, of course, feature importance. Feature importance allows you to get a sense of what were the most important attributes inside my data set that helped me make my prediction. Now, the cool thing is in this TwitterBots data set, the unstructured data, like some of the text description, was really important. And a lot of the other metadata helped add up to a more predictive model as well. And if I wanted to get a sense of what attributes inside the text are actually the most inspirational for the model to be able to get a sense of whether or not a user was a bot or a human, I can actually click into any of the feature descriptions and get a sense of what actually was picked up as a higher or lower likelihood version of this. If I have a model that I'm happy with, I've looked at all of its different metrics, and I actually want to start to just think about, hey, I've looked at how long it took to train. So this model only took about 15 minutes to train. I can think about how I actually want to operationalize it. And inside of Predabase, there's three ways that you can use to operationalize your model. You can export out that model if you want to run it locally, for example, and you have your own stack that you want to be able to export it to. If you liked the way that you saw me interact with the LLMs, you can actually just deploy this to an endpoint in one click. And so what this is going to do is deploy my machine learning model to a serving engine, basically just a hosted endpoint that I can then start to use just as an API. And so I can pass in any of the data that I want and get a prediction directly back. Or if you're interested in doing batch prediction, so this classify each user as a human or a bot, but over my data set using a more structured kind of language, we also have this interface that goes alongside our LLMs called Pequel. And Pequel is essentially a new language or just a series of extensions on top of SQL that allow you to be able to write predictive queries in just one line. And so everyone's familiar with my basic SQL query, select 10 users from the TwitterBots dataset. What that'll do is return a table very similar to this, essentially selecting 10 rows from my TwitterBots dataset. What I think is really cool, though, with Pequel is that because I have a model now trained for my account type, whether or not that user is a bot or a human, I can translate this single line SQL statement into a predictive statement in just one line. And so here what I'm going to say is, instead of select 10 users from the TwitterBots dataset, predict the column that I'm interested in. In this case, I'm interested in predicting the account type given these 10 users. And when this query executes, what you're essentially going to see is that we're going to add a new column to the table. And that column is going to be called account type predictions, with the predictions coming directly from the ML model. And so here, what I have is a model that was trained that we just saw how to be able to build, classifying each user as a human or a bot. And you can see in most cases, the model does well. And in some cases, of course, there might be some room for improvement too. So this is how we think about marrying the ability for you to build a smaller custom model, as well as being able to do batch prediction over your entire data set with it in a language that I think feels very familiar to anyone that might speak SQL. And let me actually go ahead and pause here. There's a lot that I've shown you. We're getting started in Predabase, where a lot of our users might start, is they might just start by pinging an LLM. What is the capital of Italy? From there, they might decide they want to customize it to their data set. If you want your LLM to read your data set, you could choose one to index. If you want your LLM to be able to run predictions for each row in your data set, you could do it for batch inference. And if, like the TwitterBots example, you decide that it's one that the LLM does okay at, but not as good as you might want, you can actually train and build a much smaller custom model directly inside the model repository to be able to solve that. And once you've done that, you can deploy and operationalize it in a very similar way in workflow that you might have seen for the LLMs themselves. If I've gone a little bit fast in this demo, it's just because I want to make sure that I can save some time for questions. But the really nice thing is, if you request a trial, and we'll make sure you get approved, if you request a trial, what you can actually do is get into our documentation, and you can see our quick starts directly here. And what's I think really useful is we have a quick start, both for how you can get started with LLMs, and you can actually see this wine reviews data set that I walked through today and be able to walk through these exact same steps. And then also switch to what it looks like to be able to do a different type of tutorial with supervised machine learning. So all of that's available in our documentation. And it actually goes a lot deeper. So if you want to know how you can fine tune an LLM, how you can train many different types of models, or just explanations for the different visualizations that I've picked up, all of it's available in our documentation. And of course, since we're especially a technical audience here, I want to mention that everything you just saw me do through the UI can actually be done programmatically as well. And so if you wanted to use this through an SDK, and you wanted to do this more programmatically, like running your queries either through a Python SDK or just a command line interface, you can actually do so directly. And so our user guide and our SDK guide will walk you all the way through this. Please go ahead and just visit predabase.com if any part of this was interesting for you. If you want to click try Predabase, you can go ahead and replicate everything that you saw in this demo in case it was interesting to you. And so, I don't know, sorry, I think I just realized that I was clicking through documentation. I don't know if everyone had a chance to see it, but hopefully you did. So this would be our quick start for supervised and LLMs. And again, if you go to predabase.com, you can request a free trial. Great, so I think that's most of what I wanted to be able to show you today. Let me go ahead and take the remaining 10 to 15 minutes and see if I can answer any of the questions that may have been asked for in chat.
All right, so a lot of questions came in, Dev, and we had the team live answering, but maybe for the benefit of the group, we'll just start going rapid fire through them. So someone had asked, what is our level of support for open source image models? And there was actually a follow-on question around, do we support audio modalities as well? So maybe I'll let you address both those together.
Yeah, that's great. I always enjoy when I can answer a question by showing you. And so maybe what I'll just do is, if I can take over the screen for one more second, I will go ahead and show you what the support for open source image models looks like. And so what I'm going to go back to is I'm going to go back into my Predabase instance, and I'll just show you that the very short answer is that we support a number of open source image models, all the way from your more conventional things like ResNet to some of the more cutting edge versions like VIT, which is a transformer-based image model architecture that I believe came out of Google. To show you a little bit of what that actually looks like, maybe I'll go ahead and just give you a quick flavor for it using the TwitterBots data set. So in the TwitterBots data set, I have this profile picture image data field. And so if I go into my choice of models for my image, you'll see that the default is a stack of CNNs, convolutional neural networks, which we think provide a good trade-off between cost and performance. But here are all the different image models you have available out of the box. You can use VIT, AlexNet, EfficientNet, Inception v3, MobileNet, ResNet, the many different types of nets essentially that exist out of the box. And again, like everything else, you can use them pre-trained and then fine-tune them on your data set. So that's kind of the support for the image models overall. And if you wanted to understand a little bit more about the different types of models that we support, of course, you can go to the Predabase docs, or Ludwig AI will have everything available directly in our configuration section. So you can see this from our open source documentation as well.
Nice. And as we answered in chat as well, we do support audio modalities, and I actually shared a use case in there for someone in the chat around a respiratory recordings use case that was done on Predabase with audio files.
Right. Oh, I'm sorry, I missed that second part of the question. Yes, audio modality is also supported, and you can actually go again to the ludwig.ai site and see an example there, or the one that Michael has just pointed out in Predabase.
Awesome. How would you compare sort of the Predabase offering for LLMs compared to like a ChatGPT?
Yeah, it's a great question. We think ChatGPT is an amazing place to get started. ChatGPT is a great place for you to be able to interact with a model very easily and get a sense of like where it is. But it's hard to put ChatGPT into production. And that really tends to be for two types of reasons. The first is, and this is actually something we've noticed is really problematic for a lot of our users that we've surveyed. You need to be able to give your data to ChatGPT. So if I wanted to, for example, index the data set, or if I wanted to run batch prediction, I need to send it on over the public internet to ChatGPT. Whereas with Predabase, you can deploy Predabase inside of your own virtual private cloud. So your data never needs to leave your environment. And so the first part of this answer is I would say Predabase is more private. And we're a lot more private by being essentially big believers in the open source. We think open source models are the future. And that's the type that you can deploy inside of your environment. The second is I think we make it a lot easier to customize towards your data set. So you saw a little bit of what you can do directly with dataset indexing, where I essentially have my LLM read over my dataset. And you saw a little bit of what you can also do with dataset for batch prediction. The one piece that I didn't highlight is you can also fine tune the LLM on your dataset. And I think it just becomes a little bit easier to be able to do that in a private way, especially with open source models using Predabase. That's probably our primary difference.
All right, here's a really cool question. Let's see what your response is, Dev. Someone's referencing they do a lot of supervised learning inside of their organization. Curious how you might think about augmenting supervised models or supervised workflows with LLMs. Curious how you think about
Love that question. Yeah, I love that question. I think one of the really nice things is I believe that the Predabase platform is a really good fit for if you're trying to do a combination of LLMs and some supervised machine learning as well. So one way that I think I would look about augmenting it is I would take my initial data set and I would use my LLM to be able to add new features or feature augmentation directly from that underlying data set. So as a good example, what I could do inside of Predabase is, you saw me say something like classify the variety of each wine. What I could easily ask my LLM to do too is like add classify the sentiment of each wine, or tell me like if this wine seems snobby or not snobby. And essentially use this as a series of additional columns that the LLM generates per data set. And then I can use all of these new features to be able to train a supervised machine learning model. And there's two benefits, I think, of this. The first is if you don't have a lot of labeled data or you don't have enough signal necessarily in your underlying data set, but you think that the LLM can essentially, like if you had a human annotator, for example, that was reading these descriptions, or an LLM that can essentially augment this, you get more signal using the benefits of all the pre-trained large language models. And then the second is you can kind of compress all of that knowledge down into a much smaller model that's more efficient to serve. So you can take that LLM, figure out what its sentiment was over the 100,000 wine reviews, for example, that you'd access to, then train a smaller model to be able to do a different classification task or the same one. And now the smaller model is probably 100th or 1,000th of the size of the full LLM. And so it's a very nice way to be able to combine both.
Awesome. So I want to ask specifically about importing models from Replicate. I'm not sure if you're familiar with Replicate as a framework, but maybe we just talk about sort of the model import sort of story that we support. And then, and then the sort of follow-us on to that was like, can use them as our own API or just push them into an API?
Yes, great questions. And so I will answer once again just by showing you actually. So if you want to add any model architecture that we don't, first of all, we support many model architectures out of the box. I think, for example, Replicate makes it quite easy to be able to use Hugging Face models. And I think, Predabase provides essentially access to all the Hugging Face models right out of the box too. So for the vast majority of cases, you're likely already covered. However, if you want to add a model that we don't already support, we actually have pretty extensive documentation on how you could add any new model directly into Ludwig. And so it's just as simple as, essentially adding a new encoder. And this actually extends not just for new models that we might not support, but let's imagine you have a very specific metric you want to compute that we don't support. It's all open source, and you can actually add these very easily as you might want to. The second part of the question is, can I easily deploy or serve that model? And there also the answer is definitely yes. And so inside of Ludwig, you could serve a small model directly on top of your laptop, using this serving story. But if you actually want to make it ready for like a more production ready use case, in Predabase, you can deploy a model in just one click. And so what that looks like is I can go into a model version, click, let me go into a model version, click deploy. And all I'll do is I'll give it a name. So here's my model version, live demo, leave a comment, and I can deploy it. Once I deploy it, it'll spin up in just a couple minutes. And what you'll be able to see is you get this REST endpoint that you can essentially use for serving. And that REST endpoint can then be pinged from any application downstream.
Awesome. There's actually a question about an OpenAI. This is along the lines of what we just answered. Open source model called Jukebox, which is like for music generation. Do we support it? I don't think we have it out of the box, but to your point, it can easily be added.
Yeah, we don't support today. We don't support closed source models. Although it's something we're considering. Any open source model that you might want to be able to be interested in, for example, any open source model that you've found in Hugging Face that you're interested in, you can just deploy inside of your environment using a simple one-line command. And so I think for now, the closed source models are just something we haven't prioritized as heavily, but we're kind of large believers in the open source.
Great. So there's some questions about pricing and maybe just sort of I think that the best answer for that is like connect with David, who's actually in the chat, answering many of the questions, and our sales team, and can kind of go through that, how we structure those. Because people are curious, like what happens after the free trial. And so it actually asked specifically, how does the platform scale, from one user maybe to many and across the board?
Yeah, great question. I mean, I think with respect to pricing in particular, please do reach out to David. We're happy to work with you on the pricing that I think, makes the most sense. With respect to how does the platform scale, I think that the key thing that I would actually point out is that there's two dimensions for scale. The first is adding users. We think that the collaboration capabilities in Predabase are pretty cool. So you saw the model repository of our Twitter bots. We had 6 different users training different models there, forking each other's, changing one line here or there. And that all gets tracked very easily in the model lineage and repository. And the second area for how it scales is in terms of the size of the task or the complexity of the task that you're doing. So let's imagine you have a lot of data that you're trying to do this task on. We have this serverless compute abstraction that I mentioned called engines. Engines are basically just a flexible way for you to never have to care about your machine learning infrastructure. What we'll do is we'll right size the compute that you need. And this compute can essentially scale up from 0 GPUs and just CPUs to dozens of GPUs or 64 CPUs. And we do the efficient part of the data pre-processing on CPUs, the model training on GPUs. All of that gets abstracted away. Although of course you have full control if you want to scale back or up the amount of compute you're using. And so we'll recommend a right-size compute configuration for up to the data set size that you're interested in. And we've benchmarked on really large data sets as well. And so if you're interested in data set scale, please reach out to us. We have some benchmarks that might be interesting for you to see. We're happy to talk through it.
Awesome. Another question that came in, I think is relevant to the demo actually, Dev. Someone said, before you get into your models, the essence of your data is revealed through pre-processing. Did we cover that in today's session? They might have missed it. Thoughts on how we handle pre-processing?
Definitely. I like that framing of the essence of your data is often revealed through pre-processing. So let me see if I can show you a bit of how we might think about it. The first thing I think often that comes about is just trying to get an understanding of the essence of your data. And so we have a data previewer that tries to give you a sense of what we think are the repeatable set of tasks that end up being important for what you're looking to do. And so you can see the distributions, if things are unbalanced, what the most frequent classes and least frequent classes are. You can actually preview your data essentially and get a sense of imbalance ratio and a number of different things directly through this view. And so I think this is a really useful way for you to be able to first understand what your data looks like and doesn't look like. And then the second is you might want, there's oftentimes 2 parts of data preparation once you've got here. The first might be data wrangling, which is I have data in 7 different sources and I need to connect them. That part usually happens upstream of Predabase. So you'll do that in your underlying data warehouse or your data lake, and then connect that data warehouse or data lake into Predabase. The second part is, okay, I've gotten all this description. It's great, but it's all raw text, and I need to clean that text. And there we actually have as part of our machine learning model pipeline, I'll go through this quickly, but you can actually see this in documentation as well afterwards. As part of the machine learning model pipeline that gets generated, you actually have all of these pre-processing capabilities that are built for you out of the box. So this model pipeline goes from input feature to pre-processing all the way to model encoding, decoding, and outputs. And you can customize the pre-processing however you want. So for example, for text, we do a lot of custom pre-processing like match sequence length. We tokenize text, we lowercase it. You can choose any of this. For images, we have a different series of pre-processing that makes sense. For numerical, we can normalize, handle outliers, and do many other types of things kind of right out of the box. And so data pre-processing just becomes part of this machine learning pipeline that you get configured for you out of the box automatically.
Awesome. So maybe we'll just do, I have a response to one question. I'll give you one more, Dev. So someone asked, do we support Helm, which is a new method for evaluating large language models? It's actually something we're actively looking at adding to the platform and working on. So that's to come. And then in the one more final question for you is, Dev, how do we support, do we plan to support generative use cases or adding plugins for those?
Definitely. So we support generative use cases today. And so if you, and we support generative use cases in one of 2 ways. The first is you can use your large language model out of the box to be able to do a generative use case. And so if you remember my wine example, what I asked my large language model to do was generate, an occasion that the wine might be a good fit for. And so that I think is a good example of a generative use case, but I could also ask it to, write me an AI joke. I've never tried this before, so I really hope it's an appropriate answer. But I can use this LLM to be able to do anything generative, and that of course is useful and available out of the box. But those more what have I run this on? I ran this on Twitter bots. But what I actually could do instead is instead of just being able to do like a generative model for an LLM that's maybe a little bit more generic, I can also build a more custom model directly inside of Predabase. So here, if I look at the Twitter bots example, just once again, you see all this different types of data. And here I was trying to predict whether or not the user was a human or a bot. But what if I wanted to do something very different? What if instead of trying to predict whether or not the user was a human or a bot, what I actually wanted to do was try and generate the description that the user would have written for themselves in their bio. I can actually use description as an output field. And what that will do is it will use some of the other features here to be able to write out what it thinks is the right description for this Twitter user bot. And so these types of generative models can be built directly inside of Predabase as well. And it becomes a very easy way for you to be able to customize them towards the specific things that make your data set interesting.
Super cool. I love that last one, right? A bot description for the profile. All right, well, that's time. We're just over. Thank you so much, everybody who was able to join today and all the great questions. The recording will be sent out after. If you're interested in a free trial, please fill it out, and we can definitely follow up directly with you and talk about pricing. As Dev mentioned, we work with the organizations who are interested in the platform to make it work for you. And thanks again, and we'll talk to you later. Thanks, everybody.
Thank you, everyone. Really enjoyed it.